There were a few areas in this project that were more challenging than we initially expected. On the front end, the real-time map was probably the biggest hurdle. Getting Leaflet to update smoothly with a 3-second polling loop required a lot of iteration. Early versions had issues like duplicate markers and visible flickering. We also needed to manage separate clustering groups for clean like versus alert markers, which is not something Leaflet supports out of the box, so that required additional customization. On the back end, stateful detection introduced its own complexity. For example, speed and bearing anomaly detection both depend on comparing the current GPS reading with the previous one for each device. And a synchronous fast API environment handling the current requests, maintaining that per device state raised concerns about race conditions. We had to carefully structure how state was accessed and updated to ensure consistency. Another challenge was implementing the Habersign distance and bearing calculations from scratch. This involved handling edge cases like crossing the antimeridian, verifying our results against known distances, and making sure all radian conversions were correct before we started, tuning detection thresholds. For these challenges, we learned that layering the detection methods is essential. Each individual method has its own blind spots. So, for example, the speed checks, they can miss slow drift attacks, geofencing can miss spoofing within a valid area, and HCOP can be manipulated. But when we combine these methods, they provided much stronger overall, coverage. The other key lesson was improving how we structured the demo. Early versions only showcase attack scenarios, which made it harder to understand what normal behavior looked like. By interleaving clean driving data with attack scenarios, we made the system's behavior much clearer and easier to interpret.
So there are two things that I would prioritize if we kept building this. The first is machine learning. Right now, every detection threshold is hand-tuned to 60 meters per second, 160 degrees with a zero point 0.5 HDOP. Those work well for obvious attacks, but a sophisticated attacker doing slow drift under those thresholds is going to slip right through. Training an anomaly detection model on historical baseline data from each device would close that gap. The second is multi-satellite validation. The core reason GPS spoofing is even possible is that we are only listening to one constellation. If we cross-reference against GLONASS or Galileo simultaneously, single constellation spoofing becomes a lot harder to pull off without being detected. Long term, PostgreSQL for production scalability, WebSocket push notifications instead of polling, Docker cons con containerism for deployment, RBAC for multiple analysts can use the same instance. The fundamentals are solid. The detection pipeline, the signaling, the SOC workflow, all that is production ready in concept. The next phase is hardening it against more sophisticated attacks and making it deployable at scale.